This type of problem is, will a precipitate form? This is going to combine a couple of concepts. One, KSP. On the AP exam, they will always tell you what it is they are interested in terms of the compound that would be precipitating. We're going to look at, are the ion concentrations high enough in order for a precipitate to form, which means we're going to be calculating Q, and we're going to compare Q to KSP. But in order to find the ion concentrations, we're also going to have to handle dilutions. Remember, when we're doing dilutions, the equation we most frequently use is M1V1 equals M2V2. These two solutions, when they're being poured together, are diluting each other. So if I want to find the barium ion concentration after dilution, I'm going to look at the barium ion concentration before dilution, which started off at 0.04 molar with 200 milliliters of it. After dilution, its concentration will be M2. And at this point, we'll have combined 200 milliliters of one of them with 800 milliliters of the other. So we'll have a total of 1,000 milliliters. 0.04 times 200 divided by 1,000 gives me a new barium ion concentration after the two have mixed of 0.008 molar. I need to do something similar for the fluoride. So the fluoride before mixture was 0.06 molar, and we had 800 milliliters of it. Once the two have combined, our volume is 1,000 again. 0.06 times 800 divided by 1,000 gives me a concentration of 0.048 molar for the fluoride. All right, the compound that we're interested in is barium fluoride, which is BaF2. I need to write a KSP expression, and after I've written a KSP expression, then I'm going to plug in the ion concentrations to calculate Q. My KSP expression will be the barium times fluoride squared. Calculating Q, I'm going to plug in the present concentrations. Barium was 0.008, the fluoride is 0.048, and the fluoride is squared. 0.008 times 0.048 squared yields 1.8 times 10 to the negative fifth. I need to compare that to the KSP value. The KSP value was given to us in the problem statement as 1.7 times 10 to the negative sixth. Is Q greater or less than KSP? Q is greater than KSP, which, like an equilibrium problem, means we're going to get a left shift. If we're getting a left shift in this reaction, these two ion concentrations are too high. We're going to get a left shift, and when we get a left shift, it's the solid that's forming. The solid that forms in solution is indeed a precipitate. So whenever Q is greater than KSP, your answer is yes, a precipitate forms. Obviously then, if Q is less than KSP, no, a precipitate does not form.